Okay, so we're doing a deep dive today all about lunar meteorites.
Wow.
You sent over some incredible research and articles about these pieces of the moon that have landed right here on Earth.
It's amazing, isn't it?
And I am already fascinated by the idea that you can actually hold a piece of the moon in your hand.
Yeah, it's incredible.
So where do we even begin with all this?
Well, one of the things that makes lunar meteorites so fascinating is that they represent a random sampling of the moon's surface.
Oh, interesting. So unlike the Apollo missions, which only landed in a very specific area,
Exactly. They landed in a limited area. Yeah.
these meteorites come from all over,
They do.
giving us a much broader understanding of the moon.
Right, a much broader understanding of the moon's diverse geology.
Okay, so before we get into all of that, let's back up for a second.
Okay.
How do these lunar meteorites even get blasted off the moon in the first place?
Well, unlike Earth, the moon has a very thin atmosphere,
Right.
which means it's constantly being bombarded by meteoroids.
Oh?
And we're not talking about like tiny pebbles here.
Some of these impactors are massive and traveling at insane speeds,
How insane are we talking?
like 27,000 to 90,000 miles per hour.
That's really fast.
It is.
That's mind-boggling.
It is.
So what happens when these meteoroids slam into the moon at those speeds?
Well, when a large enough meteorite hits the lunar surface, the impact can eject lunar rocks with enough force to escape the moon's gravity.
Oh, wow.
But to break free, they need to be launched at a speed of at least 1.48 miles per second,
1.48 miles per second.
which is faster than a speeding bullet.
Wow. Okay, so these lunar rocks essentially get catapulted into space.
Yeah.
Where do they go from there?
Well, these ejected rocks can end up orbiting Earth or even the sun
Oh, wow.
for years, decades, even millions of years.
It's like a cosmic pinball game with these rocks bouncing around until they finally land on Earth as meteorites.
That's a great way to put it.
That's incredible to think some of these were on the moon relatively recently.
Oh, absolutely.
Yeah.
The Kalahari 008009 meteorite is believed to have been ejected from the moon just a few hundred years ago.
Wow.
Talk about a quick trip.
Yeah.
On the other hand, the Doafar 025 meteorite took a leisurely 13 to 20 million years to reach Earth.
That's amazing.
So each lunar meteorite carries a really unique history.
That's wild. But okay, let's say one of these lunar rocks lands on Earth. How do we know it's actually from the moon and not just a regular Earth rock?
Ah, that's a great question.
Yeah.
It can be tricky,
Right?
especially for those that are found in really harsh desert environments.
Oh, right. Yeah, because I know like a lot of meteorites form that distinct fusion crust as they burn through the atmosphere.
Exactly.
But I would imagine that that could get worn away over time,
It can wear away over time,
especially in a desert.
especially in a desert, yeah.
So what do scientists look for then when they find these rocks and there's no fusion crust?
Well, this is where the real detective work comes in.
Okay.
Scientists analyze the composition of the rock,
Okay.
specifically looking for cosmogenic nuclides.
Cosmogenic nuclides.
Yeah, these are special isotopes only created when rocks are exposed to cosmic rays in space. Oh, wow.
So these cosmogenic nuclides are like a fingerprint unique to space rocks.
That's a great way to put it. It's like a cosmic signature.
Yeah.
So these isotopes help scientists confirm if a rock has been exposed to the harsh radiation environment of space,
Exactly.
which is a key indicator of its origin.
It is.
Okay, that makes sense. So are these lunar meteorites just cool souvenirs from space? Or can they actually tell us something about the moon itself?
They're so much more than souvenirs.
Okay.
Lunar meteorites are like time capsules from the moon, providing invaluable clues about its formation,
Wow.
its evolution, and its relationship with Earth.
So they're really important then for understanding the moon.
They are. In fact, they're even filling in gaps and challenging some of the assumptions we developed from the Apollo missions.
Really? So I thought the Apollo missions gave us a pretty good understanding of the moon.
They did. But remember, the Apollo missions landed in a relatively small area.
Okay.
In this area called the Procellarum K-Reap terrain.
Procellarum K-free terrain.
Yeah. It turned out to have unusually high levels of radioactivity.
Oh, okay.
So our initial understanding of the moon's composition was skewed by this limited sample set.
So the Apollo samples were like looking at a small, unusual piece of a much larger puzzle.
Precisely.
Okay.
What's fascinating is that lunar meteorites coming from all over the lunar surface have shown us that most of the moon actually has much lower levels of radioactivity.
Oh, wow.
Yeah.
Okay, so that's one way lunar meteorites are changing our view of the moon. Are there other surprises they've revealed?
Absolutely. Lunar meteorites have revealed the existence of unique lunar rock types never found during the Apollo missions,
Oh, wow.
hinting at a far more diverse lunar geology than we initially imagined.
Like what? Give me an example.
Well, for instance, there are basalts from the Northwest Africa 773 clan.
Northwest Africa 773.
Yeah, which are unlike anything in the Apollo collection.
Wow.
Or the incredibly rare anorthositic troctolites from the NWA 5744 clan.
So each new find expands our understanding of the moon's complex history.
Yeah, that's a great analogy.
It's like each meteorite is a new chapter in the story of the moon.
Exactly. And perhaps the most intriguing chapter is the one we haven't quite figured out yet. The mystery of their origin.
Right, man.
Well, despite all the lunar meteorites we've found and all the high-resolution images we have of the lunar surface, we haven't been able to definitively match any of them back to their source craters.
Wait, seriously?
Hmm.
We can't pinpoint where any of these meteorites were launched from.
We can't.
I would think with all of our technology, we would be able to do that.
You would think so. But even though we know that impacts creating craters as small as a quarter-mile wide could launch these meteorites,
Wow.
those craters are incredibly difficult to spot on the vast, heavily cratered lunar landscape.
So it's like trying to find a specific grain of sand on a beach.
Exactly. And while we haven't found a definitive match yet, it doesn't mean we're completely in the dark.
Okay.
Scientists have uncovered some intriguing clues.
Oh, like what?
Well, remember how we talked about the iron content of lunar meteorites, offering clues about whether they came from the near or far side of the moon?
Right, higher iron generally means near side, lower iron points to the far side.
Well, that same principle can be applied to specific regions.
Okay.
For instance, some meteorites have high thorium concentrations.
Thorium.
Yeah, which is a radioactive element that's
Yeah.
not evenly distributed on the moon.
Got it.
By comparing the thorium content of a meteorite to maps of thorium distribution on the moon, scientists can narrow down the possible launch sites.
Oh, wow. So it's like a cosmic treasure hunt, using elemental clues to track these meteorites back to their origin.
Exactly. It's a fascinating blend of geology, chemistry, and a touch of detective work.
That's so cool.
Yeah.
All coming together to unravel the mysteries of the moon.
Right.
It's amazing. And as we find and analyze more lunar meteorites, the chances of solving this puzzle increase.
Exactly.
Wow, that is fascinating. Knowing how much these meteorites can teach us, I'm suddenly very curious about how rare they are. Are we talking winning the lottery rare or finding a dollar on the sidewalk rare?
Let's just say that lunar meteorites are definitely more like winning the cosmic lottery.
Okay.
There are only about 714 officially recognized lunar meteorites in the entire world.
Wow, that's incredibly rare. And I imagine some are larger than others.
Oh, definitely. The largest one found weighs a massive 104 kilograms.
104 kilos.
Yeah, part of the NWA 12691 find.
Wow.
But on the other end of the spectrum, some meteorites found in Antarctica are as small as a few grams.
Oh, wow.
Yeah, so it's quite a range.
That is a huge range. I remember you mentioned earlier that some people actually buy and sell these lunar meteorites.
Yeah?
Is that right?
Yeah, you can actually own a piece of the moon.
Wow.
The
yeah.
prices vary greatly depending on size type and historical significance.
But I have to ask, is there a black market for these things? How can you be sure you're not buying a fake?
You bring up a good point.
Yeah.
Just like with any collectible, there are always those trying to make a quick buck. So it's crucial to be cautious and buy from reputable sources.
That makes sense.
Mm-hmm.
So let's say we want to go on a lunar meteorite hunt of our own. Where should we be looking?
Okay.
Any hotspots?
Most lunar meteorites have been found in hot deserts, like the Sahara in Oman,
Okay.
and surprisingly, in Antarctica.
Antarctica?
Yeah. And here's the interesting part. All of them have been finds, meaning none have been observed actually falling.
Wait, really? No one has ever actually witnessed a lunar meteorite falling to Earth.
That's right. It's a bit of a mystery.
That is strange. So how are people finding these lunar meteorites if they're not seeing them fall?
Good question.
Who are these lucky folks making these incredible discoveries?
It's a mix of chance encounters and dedicated searching.
Okay.
Sometimes local people just stumble upon them while going about their daily lives.
Wow.
And other times it's dedicated meteorite hunters who
Right.
have made it their mission to scour the landscape for these cosmic treasures.
So it sounds like finding a lunar meteorite requires a combination of luck and a keen eye.
It does.
But I bet it's not as simple as picking up any old rock and declaring it a lunar meteorite.
Definitely not. Identifying a lunar meteorite in the field can be tricky, especially since they can often resemble Earth rocks.
Right.
Even seasoned meteorite hunters need to run tests to confirm their lunar origins.
So for those of us who might dream of finding our own lunar meteorite, What should we be looking for?
Okay.
Any telltale signs?
Well, the most obvious indicator is the fusion crust we talked about earlier.
Yeah.
It's a thin, dark, glassy coating that forms as the meteorite burns through Earth's atmosphere, however many desert finds,
Yeah.
due to exposure to the elements, have lost this crust over time.
Oh, making them even harder to identify.
Exactly.
So it's like searching for a needle in a haystack, even if you know what you're looking for.
It can be.
And then even if you find a promising rock, you still need to get it tested.
You do.
But imagine the thrill of holding a piece of the moon in your hand, knowing it traveled across the vastness of space to end up right there in your palm.
It really does put things in perspective.
It does. And here's something else to ponder. Even relatively small impacts on the moon, those creating craters a quarter-mile wide, could launch lunar meteorites.
Right.
It makes you wonder what other treasures might be hidden in plain sight.
It does.
Okay, I'm officially intrigued. This deep dive has already uncovered so many fascinating details I can't wait to explore even further.
I agree. There's so much more to uncover about lunar meteorites.
Okay.
And I think you'll be especially interested in what they can tell us about the moon's potential resources.
Ooh, resources, you say? Now you've really got my attention.
Yeah, it really is remarkable how much we can learn from these seemingly ordinary rocks.
Right.
Each lunar meteorite is a piece of the puzzle, helping us
Uh-huh.
understand the moon's history, evolution, and even its potential for the future.
You mentioned the moon's potential resources earlier.
I did.
What exactly can these meteorites tell us about what might be hidden beneath the lunar surface?
That's a great question.
Yeah.
Remember how we talked about the diverse types of lunar meteorites?
Uh-huh.
Like the mare basalts and unorthosis breccias?
Yeah.
Well, each of these rock types carries a unique chemical signature,
Okay.
a fingerprint of its origins and the conditions under which it formed.
So by analyzing these chemical signatures, can scientists actually get a glimpse into the composition of the moon's interior?
Exactly.
Oh, really?
For example, the presence of certain rare earth elements in some lunar meteorites strongly suggests that the moon's mantle
Okay.
could contain valuable resources like helium-3.
Helium-3.
Yeah.
I've heard of it, but to be honest, I don't really know what makes it so special.
It's a rare isotope of helium
Okay.
that's thought to be abundant on the moon,
Okay.
and it has the potential to be a real game changer in the field of energy.
Okay, now you've got my attention.
Okay.
Tell me more.
Well, helium-3 is considered a potential fuel source
Okay.
for future fusion reactors.
Fusion reactors.
Yeah. Fusion, unlike the nuclear fission we use today, is a much cleaner and vastly more efficient process.
Oh, wow.
And because helium-3 is so rare on Earth,
Right. But thought to be abundant on the moon,
Mhm.
it's seen as a potential key to unlocking a nearly limitless supply of clean energy.
Wow, that's incredible. So these lunar meteorites are giving us a sneak peek at potential lunar resources that could revolutionize energy production here on Earth.
Exactly.
Yeah.
They're like scouts from space showing us what might be waiting for us on the moon.
That's a great way to put it.
And it's not just helium-3.
Right.
Lunar meteorites also contain other valuable resources like titanium, platinum, and even evidence of water ice trapped in permanently shadowed craters.
This is mind-blowing.
Yeah.
I have to admit, I always thought of the moon as this desolate, lifeless rock in space, but now it sounds like a treasure chest just waiting to be opened.
It kind of is.
Yeah.
And these resources could be crucial for establishing a sustainable human presence beyond Earth.
This is really making me think about those impacts we discussed earlier in a whole new light. It's fascinating, but also a bit unnerving, knowing that the moon is constantly being bombarded.
It makes you appreciate Earth's atmosphere even more.
It does. Our atmosphere acts like a shield, burning up most of the smaller objects that enter it.
Right.
But the moon, with its very thin atmosphere,
Yeah.
it takes a constant beating from space debris.
And those lunar meteorites are a stark reminder that even larger objects manage to slip through Earth's defenses from time to time.
They do. They serve as tangible evidence of the dynamic and potentially hazardous nature of our solar system,
Okay.
but they also provide a unique opportunity to learn about those hazards
Right.
and how to protect ourselves.
Oh, so.
Well, remember, lunar meteorites were created by impacts.
Right.
By studying their age and composition, we can actually piece together a timeline of these impacts
Okay.
and understand the frequency and intensity of cosmic collisions
Wow.
that has shaped both the moon and Earth.
It's like using the moon as a giant impact detector.
Exactly. And this information is crucial for assessing the risks posed by near-Earth objects
Okay.
and developing strategies to mitigate those risks.
That's really important. It is. This deep dive is turning out to be a wild ride.
Yeah.
From space rocks to clean energy to Planetary defense.
It is.
But before we get ahead of ourselves,
Okay.
I have to ask about something that's been bugging me
Yeah.
since we started talking about identifying lunar meteorites.
Hmm.
We know that all the lunar meteorites found so far have been finds,
Yeah.
not falls. Why hasn't anyone witnessed a lunar meteorite actually falling to Earth?
It's a question that has puzzled scientists for years.
Yeah, it seems counterintuitive. You'd think with all of our technology, someone would have captured footage of a lunar meteorite streaking through the sky by now.
You would think.
Do scientists have any theories about why this might be the case?
There are a few hypotheses.
Okay.
One is that lunar meteoroids might enter Earth's atmosphere at slower speeds than meteoroids from the asteroid belt or Mars.
Okay.
A slower entry speed would result in a less dramatic and therefore less noticeable meteor.
So they might be out there streaking through our skies, but just not creating the kind of fiery spectacle we're used to seeing in movies.
Exactly. It's also possible that the composition of lunar meteoroids might make them less likely to produce a bright meteor even if they're traveling at higher speeds.
So it's entirely possible that lunar meteorites are falling to Earth all the time, and we're just missing the show.
It's a fascinating possibility.
Yeah.
And it highlights how much more there is to learn about these celestial travelers
Right.
in their journey to our planet.
It's amazing to think that we're still making new discoveries about
Yeah.
something as seemingly straightforward as a falling rock.
I know. And it's not just the scientific aspects of lunar meteorites that are fascinating. There's also a deeply human element to their story that I think you'll find intriguing.
Oh, tell me more.
Well, we often focus on the scientific breakthroughs and the data,
Right.
but behind every discovery, there's a human story.
Yeah.
And the stories of the people who find these lunar meteorites
Uh-huh.
are as captivating as the science itself.
I can imagine. Especially considering how rare these meteorites are finding, one must be an incredible experience.
It is, and it's not always scientists making these discoveries.
Oh, really?
For example, the Bedouin nomads who roamed the deserts of Oman and North Africa have played a significant role in finding lunar meteorites.
Wow, that's fascinating. Tell me more about their involvement.
Well, for centuries, these nomads have traversed vast, desolate landscapes,
Right.
their keen eyes scanning the ground for anything out of the ordinary.
Hmm.
They've developed an intimate knowledge of the terrain and a deep connection to the natural world.
It's like they've been conducting their own informal meteorite hunts for generations.
In a way, they have.
Yeah.
And as the scientific and commercial value of meteorites, particularly lunar and Martian ones, has increased in recent decades, their traditional knowledge has become even more valuable.
So these nomads have essentially become expert meteorite hunters.
Exactly. They've honed their skills over generations, passing down their knowledge through families and communities.
That's incredible.
They can spot subtle differences in color and texture that might indicate a meteorite, even in a vast sea of sand and rock.
It's like they're reading the language of the desert.
That's a beautiful way to put it. And their discoveries have not only advanced our scientific understanding of lunar meteorites, but have also had a profound impact on their own lives.
In what way?
Well, for many of these nomads, finding a valuable meteorite can be life-changing,
Oh, wow.
especially financially.
Yeah.
Selling a rare lunar meteorite can provide a significant sum of money, offering opportunities and security for their families and communities.
It's like the desert has yielded a hidden treasure.
It really is.
Yeah.
And it highlights how scientific discovery can have real-world consequences.
Right?
Not only for the advancement of knowledge, but also for the individuals involved.
Yeah, it's a beautiful intersection of science, culture, and economic opportunity.
Absolutely. And it reminds us to value and recognize the contributions of those who might not have formal scientific training,
Right.
but who possess a deep connection to the natural world and a keen eye for discovery.
Their knowledge is invaluable. I'm curious, though, are the nomads the only ones making these incredible finds? What about the dedicated meteorite hunters you mentioned earlier?
You're right. There's a whole community of dedicated meteorite hunters,
Okay.
often driven by a passion for science adventure and the thrill of discovery.
It sounds like an exciting, albeit challenging pursuit.
It is. These individuals often travel to remote and unforgiving locations,
Right.
braving harsh conditions and enduring long hours of searching.
That takes dedication.
Mm.
What drives them to go to such lengths?
Well, it varies.
Okay.
For some, it's the scientific value. the desire to contribute to our understanding of the universe and unravel its mysteries.
Right.
For others, it's the thrill of the hunt,
Yeah.
the excitement of the unknown, and the possibility of making a significant discovery.
Okay.
And for some, it's simply the beauty and wonder of these objects from space, holding a tangible piece of another world in their hands.
That's awesome. It's a reminder that science is not just this cold, hard pursuit of facts, but a deeply human endeavor fueled by passion, curiosity, and a sense of wonder.
Yeah.
It's really inspiring to hear about these individuals and their dedication.
It is, and their stories are just as diverse as the meteorites they seek.
Oh, wow.
Some hunters spend years searching before making a significant find, while others stumble upon a rare meteorite almost by chance.
That's incredible. It sounds like there's an element of luck involved, but also a lot of skill and persistence.
Absolutely. Identifying a meteorite in the field requires a trained eye and a deep understanding of the subtle clues that differentiate a space rock from an Earth rock.
You know, after hearing about the nomads and the dedicated hunters, and even the sheer luck involved in finding these lunar meteorites, I'm starting to feel the urge to go on a cosmic treasure hunt myself.
I understand the feeling.
Yeah.
It's a pursuit that can be both humbling and exhilarating.
Right.
Who knows? Maybe one of us will be lucky enough to stumble upon a piece of the moon.
Or maybe even witness that elusive lunar meteorite fall. Now that would be a story to tell.
It would. But even if we never find our own lunar meteorites, the knowledge we've gained from this deep dive is a treasure in itself.
Absolutely. This deep dive has been an incredible journey so far. I can't wait to see where it takes us next. You know, after hearing about the people who dedicate their lives to finding these lunar meteorites, I'm feeling a newfound appreciation for these rocks.
Yeah.
It's one thing to hear about the science, but it's another to understand the human stories behind the discoveries.
Right.
It adds a whole other dimension to this whole deep dive.
It does. It's a testament to the enduring human spirit of exploration and our innate curiosity about the world and the universe around us.
And speaking of exploration, I can't stop thinking about those potential resources we were discussing earlier.
Right.
The idea that the moon could hold the key to clean energy and maybe even help establish a sustainable human presence beyond Earth is incredible.
It is.
It makes all this talk about lunar exploration and colonization seem much less like science fiction
Right.
and a lot more like a real possibility.
It's definitely an exciting prospect. And the more we learn about lunar meteorites, the more we realize just how much potential the moon holds.
Yeah, you mentioned other valuable resources too.
I did.
What were some of those again?
Well, lunar meteorites have also revealed the presence of titanium,
Okay.
which is incredibly strong and lightweight,
Right.
making it ideal for building structures and spacecraft.
Okay.
They also contain platinum, a valuable metal used in various industries,
Okay.
from electronics to medicine.
It's amazing to think that these resources, which are relatively rare on Earth, might be abundant on the moon.
It is, and we can't forget about the water ice that has been detected in permanently shadowed craters at the lunar poles.
Water ice on the moon. Why is that so important?
Well, water ice is essential for any long-term human presence on the moon.
Right.
Yeah.
Of course, for drinking water.
Yes, but also for generating oxygen
Oh, wow.
and even rocket fuel.
So the moon isn't just a potential source of valuable metals and clean energy.
Yeah.
It could also provide the very essentials for human life.
It could. And all of this information is coming from these fascinating lunar meteorites that have landed on Earth.
It's really incredible. You know, when we first started this deep dive, I was mainly interested in the wow factor of these space rocks, but now I see them in a whole new light.
Right.
They're not just pieces of the moon. They're clues to unlocking the future. It's like the moon is sending us a message.
That's a great way to put it.
So what's next? What are the big questions scientists are still trying to answer about lunar meteorites?
Well, one of the biggest mysteries remains the source crater puzzle.
Right.
As we talked about earlier, despite all our advancements in technology, we still haven't been able to definitively match any lunar meteorite back to its specific launch site on the moon.
Right. It's kind of mind-boggling that we can't pinpoint the origin of these rocks.
It is.
Especially with all the high-resolution images we have of the lunar surface.
Right.
You would think we'd be able to pinpoint it.
Yeah. But that just highlights the vastness and complexity of the lunar landscape and the challenges we face in understanding its history.
Right.
Solving this puzzle will require further research, more detailed analysis of lunar meteorites,
Okay.
and perhaps even new missions to the moon.
It makes you wonder, What other secrets are hidden within these rocks just waiting to be uncovered?
Exactly. Every new lunar meteorite has the potential to reveal something unexpected,
Why?
to challenge our assumptions, and to rewrite our understanding of the moon and its relationship to Earth.
It's like each one is a new piece of a cosmic puzzle, and we're just beginning to put it all together.
That's a great way to look at it.
Yeah, and the beauty of science is that there's always more to learn.
Right.
Even with all the knowledge we've gained from studying lunar meteorites, we're constantly making new discoveries,
Yes.
refining our understanding and opening up new avenues of exploration.
Yeah, it's really exciting.
I've learned so much during this deep dive. I have to admit, before we started, I didn't realize just how much these lunar meteorites could teach us
Right.
about the moon, about the history of our solar system,
Yeah.
and even about the future of humanity.
It's been a pleasure sharing these insights with you.
Thank you. I hope our listeners will continue to be fascinated by these incredible space rocks
Uh-huh.
and all they represent.
Yeah, me too.
So for anyone listening who might be lucky enough to stumble upon a lunar meteorite, what advice would you give them?
First and foremost, document everything.
Right.
Take detailed photos of the rock and the location where it was found.
Okay.
Then contact a reputable expert,
Right.
like a scientist at a museum or university,
Right.
for help with identification and analysis.
Great advice.
Yeah.
And remember, even if you never find your own lunar meteorite, you can still experience the wonder of these objects by visiting a museum or exploring online resources.
Absolutely. There's a wealth of information available about lunar meteorites, and new discoveries are being made all the time.
Well, I think this deep dive has officially taken us to the moon and back.
Yeah, it has.
Thank you for joining us on this incredible journey of discovery.
It's been a pleasure exploring the fascinating world of lunar meteorites with you.